Professor Chaitanya this side, and today I will be sharing my EDA done on this data set, which is PIMA Indians Diabetes Database. So basically, some context about this database. It is originally from the National Institute of Diabetes and Digestive and Kidney Diseases. And the objective of this database is to predict if a woman aged above at least 21 years could get is if she's prone to diabetes or not, depending on some medical features such as pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes. So these are all our independent features, and outcome is our dependent features. You can call it Y. So this is where I've done my all my work. This is a code file. Um, so at the starting, I've put a bit of information about the data. Next, we start by using bash commands just to see if you're using the correct files. So I'll quickly go ahead and you can see I've already uploaded my file to work on. So ls will give us the working directory. Now we will usually install these frameworks, which is PySpark and FindSpark, to help us analyze big data. And next, we'll also include some of these files which we'll need in OS, PySpark, FindSpark, pandas, SPD, numpy, np, matplotlib, splt. And if someone is using a local machine and has yet to install OpenJDK version, the latest version, that is 8, you can use the apt command here on bash, using a bash command to install it and set his environment to this following link. And additionally, you could also use the wget command or the tar xf commands to install PySpark if using local machine. Yeah, that was it. We can run this code because on my file is already installed, so it won't give me any output. And additionally, to import a data set which is hosted online, which is the link I'll provide, you could also use the curl command to put all the data into a new CSV file and then upload it. So next we just do findspark.init. We initialize the object so it saves us time next time. And next we check the prerequisites. We'll import PySpark.sql, import Spark session. And next we just make our Spark object, Spark session object. We could alternatively, we could also use a Spark context .getter create, but I prefer Spark. So as you can see, it'll show you the Spark session name and it'll get using the getter create function. Next, we will be reading the CSV file. So there's 3 ways of doing this. The main method is using Spark. The other method is using either pandas or read CSV or using the SQL context from spark.sql. So we can run these and we'll just use df.show to see if our output is correct. So as you can see, this is the file that we could see here. These data points are the same. So we have pregnancies, glucose, blood pressure, etc., etc. Then finally outcome. Next, we could also do the same using pandas. We just use read CSV and it will provide us the same thing. Or we could use SQL context. If you are working on a database, I prefer this method. But if not, then I prefer this method. So as you can see, I'll give us the top 20 because show will only show the top 20 rows by default. Now, basic information of the file, we can print the rows and the columns using .count and .columns, length of .columns. And then we just print the schema. It shows us how we all the data types and the tree structure. And next, we can use .describe.columns to get a 2D array, basically of all the columns. So we don't need this, but it's up to the user. Next, I've used this nested for loop inside a list to make things easier and less space. And here I've just like printed the count of each data in each column using list classification. So this is just to see the number of distinct counts if it holds of importance while predicting any model. So this is what I've done. You can see we have pregnancies. These are the unique values and these are the counts of the values occurring. Next, we have glucose and B, same as the count, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. outcome is either yes or no. So it is either 260, we have 268 yeses and 0 nos. So we can move on. So now we start our first visualization that will be a histogram using that displays the count of each variable, each distinct element in the columns. So basically I've used this, or I've used plt.figure, and I've added subplots to it so that it looks neater and it consumes less space. So I've done very basic things here. I've used dot plot and I've set the figure size. Then I've provided the title. Then I've zipped these two PDF dot columns. We could have used DF dot columns also, but I prefer PDF dot columns because it was taking less space. And I've been using it like that. So we just use the zip function, we use two variables, and then we plot, subplot, and these are the sizes, and then we plot a histogram. And then basically what df.to pandas will convert. Let me show you what it can do. So right now if we have df.to pandas, and I run this, it'll give me like a array like this. And then if we want a particular index, which we have as a variable here, since we are iterating, we could just use either, like if we want pregnancies here, we could use 0. And we'll get, oh, sorry. So I need to use the name, I think, pregnancy. And you can get all the variables. So that's what I've done here. Since range is one dot from pdf.columns, code belongs to pdf.columns. We've used code as a variable, so it will iterate through the list of pdf.columns and it will provide the name. And we don't want the grid. You can set this to true and false. Again, this is all my preference. You can convert this, and then code.upper, there's a title layout. And then these are just like some positionings. And then yeah, if you run that, you can see depiction of all features that shows columns versus independent variables. So yeah, you can see pregnancies, glucose, and this is basically a graphical depiction of this file where we get the count of each data. This is the graphical representation of this. So it helps the user to determine the count easily. Next, first step of the second step of machine learning model is that we check for missing data and then we encode. So if we find a missing data that is noted by np.nan, or as nan, it depends on what function you're using, we can just use sklearn.impute. You can also use since we're dealing with big data here, this is not like a relatively big data. So we can use .mllib also to tackle the missing data. But in this case, in the data is small, we can use sklearn as well. So now we can run this and we see that basically what we're doing is we select those columns where the count is nan. So as you can see, the count is nowhere, that we have no missing values because the count of nan is 0. So that is one good thing about the data, and we can move on. Next, we have the user-defined functions. It belongs to the sklearn.functions.udf module. And PySpark allows us to define user-defined functions to automate displaying or modification of data through the method we define. So for this, we'll import these two modules for PySpark.sklearn.function import UDA, and from PySpark.sklearn.types import string type. Now in our table, as you can see, so I would prefer to skip this method because in encoding data, this will we won't have to encode this data categorically. But just for a test, I've mentioned how we can change the outcome from 1, 0 to yes or no. So basically 1 means yes and 0 means no. So what we will do here is we will drop this outcome column. We will not include it in our final table. And instead of that, we will replace each occurrence of 1 and 0 by yes or no. So using that, so to do that, I've used a very simple UDF command that is basically a lambda function. So this is the syntax for UDF function, that is lambda function goes here, and the data type. So the data type is string type because it's yes and no, and this is how you've done it. So you do this, you run this, and then you basically call the width column function. You call the new name, and then the last call, the method you want to apply the column on, And then we are also dropping the final column. So I did it in one line. You can do it in two separate lines by creating two different objects, not a big deal. So when you run this, and then finally when we show the data, you can see that the new column that is named has diabetes has showed up here and includes y and y and y and that corresponds to 1 and 0, the binary outputs. And then also you can see that I've dropped the outcome table. So I would recommend skipping this because 1 and zeros will help us in and go. We won't have to do encoding data categorically on that. But now since I've done this, I would have to do it, but it's not a big deal. Now we just print the data frames to just see that the columns have been updated. As you can see, the outcomes has been dropped and has diabetes has been inserted in the list, and then the data type is string. Now, I think I've done is to like in this table, if you can see, we have age in number that is 50, 51, 31, 32, 21, 23, 33. So instead of doing presenting age like a number, I've tried to represent it as like a string. So like if age is under 25, it'll show under 25. If it's between 25 and 35, it'll show between 25 and 35. And the same with 35, 50 and over 50. And if it's above that, it'll show any because then the age won't be possible. So this was also very easy. I defined a function called age categorize, and I just pass age in it as a parameter. And basically, this parameter is going to be the column which we're going to pass. So age call, I make a new object, and then I categorize, call the UT function, and I just pass this function here. Then I again call the width column method, and this is the new column name which I want, and then I call the UTF object, and then I pass age into it. So I run this code, and then df.show. So you can see that the original column that was called age has been not dropped because I've not called a drop function. So if you want to do that, I would just call drop age. So I think that should work, and then it'll drop age, and you can see categorize age. So yeah, this was basically to help users gather more information about the data and be more precise. So next, we create a user-defined method that displays stats like average, max, min, and count of a specific features where we group by age. So say, let me quickly go back to the table. So say we have ages here called, okay, second. We can do this here. So let me all 15, 10. So we run this, and now you can see that we have all different columns over 50 between 25. So what you're doing is we're trying to call the group by function. In SQL, you might know what a group by does is basically if it will count all the distinct elements and it will group by the parameter we passed. So what we want to do is that like we are going to group by the stats. So like if over 50 has 35 here and over 50 has 45 here, we want to group by all the over 50s together and then calculate the average, max, min, and count of a specific parameter. So it could be pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, or diabetes predictive function. So for that, I've created my own function, and I've done this using string formatting to make this quick. So we start by importing SQL function as f, and then we import a window, and then from SQL functions we import star. It's basically and then we start here. So this might look complicated at first view, but it's not. So this is the function which I've created where I pass window as a parameter and a feature, the feature which we want to get. So the feature could be pregnancies, glucose, blood pressure, skin thickness, and so now we again do the same thing. We select those columns that is categorized age because we want to group by age here. So and feature. So we select both of them and then we group by categorized age. And then we use this aggregate function that is provided in the SQL class, and we aggregate these all. Aggregate will basically create a table with these many columns. So we will have five columns in our table. These four and the fifth one will be the categorized age. So in the first column, we want count of feature dot alias user count. So that will basically give us the count of each age group. Next, we want the mean, the same thing, but here I've used string formatting. Instead of making a separate function for BMI, insulin, skin thickness, everything, I've just string formatted so that it becomes more easy. So I've rounded this to two decimal places for aesthetic purposes. Then the same with minimum, same with maximum. And then I've used the, and again, this is, I've used it in one line, so it looks very complex, clustered, but you can create different objects. You can keep on doing it. So next I've done with column total. And then in total, it'll give us the sum of user count and then over window. Then again with column percentage will calculate the percentage of the user count divide. So this is basically the formula for percentage, and I've rounded to two decimal places. And again, column total dot, and I've this last part is not compulsory. I've sorted it ascending order just for setting purposes. So I can run this, and then I'll run this window object I've created, and then see. So this is how you do it. So there's two ways of doing this. So either you could pass the columns, you could call df columns, which will give you a list of all the columns, and then you can pass whatever index you want, or you could just call a string here. So I would prefer this because when we are dealing with unknown data, we don't know what these colonies are going to be. So you can use this. So you can see we have categorized age, user count, pregnancies, average, pregnancies min, pregnancies max, and percent. Percentage, this was this function with column percent. Then count was this function, total sum user count. And then this is how you group by age. And these are the averages. These are the min, and these are max. So next we can do it on the same on BMI. I think this is insulin again. So we can just run this. Insulin will show the same, and then we have another thing called skin thickness, which is also the same. Now, I can delete this real quick. And then lastly, we have to plot all these results in form of a pie chart. So I was testing around with how I could do that, and I found plt.figure to be the best way to do it. So what I did is, these are the two methods I used. So basically, what this method will do is df.columns returns a string. So df.columns is a array of strings. So what I want is I only want the first six, because if you go up, you see 1, 2, 3, 4, 5, 6. These are the only features we are um, going to plot in the pie chart. We don't need these features to be plotted in the pie chart. So I've only included from 0 to 6. So is what I was trying here. So it gives me till BMI, from pregnancy to BMI. Next, I've used NumPy to convert it into an array, into a 2D array, and I've used two just to get the district count of categorized age. So if you can see here, like here you have over 50 two times, between 25 and 35 6 times. So to reduce that, I've just converted it into a 2D array and got the distinct count of each one. So this also 2D array type is object. So we run that. Sounds good. Next, since we also know that matplotlib.plot will expects a 1D array as its argument. So we'll just use np.flatten. You can do it using other methods as well. I've used np.flatten. So it will basically convert this thing into a 1D array. You can see two braces here. There's 2D array, but here's only one braces. So now this is basically the same thing that we did. I did above. It's a bit slightly more complex, but it's no big deal. So I've again used two variables I and num, and I've zipped df.columns this thing, which is this list, and then range 1 to 7 because we have 6 columns, and then again the size, and then labels is equal to np.array, and then it's basically the same thing, and I've flattened it. And then this is the pie chart. Explode is these are all not mandatory. I've done it for aesthetic purposes. Explode is basically, if you can see this thing, this a bit outside the pie chart compared to this, so it looks good. So what you do is like you can just do this, jump this, uh, like put this as 0, and then this again, and I think this time will be another cell that'll be popped up. So you can see this time it's the green cell that's been popped out. So yeah, just for aesthetic features, this is auto PCT, everything shadow true, start angle 140. So these are all these are the main things we're concerned with. Labels as equal to labels. So labels is basically the array. It's basically this thing what you've done here. How we flattened it to a 1D array. That's what you've done here. So these are the labels. If you can see, under 25, over 50, between 25, and then the title name is going to be the same thing. That is I, because I is in df.columns. So that is the title name. And then it'll put the pie chart by itself, and then again tight layout. And these are all aesthetic settings. And you could improve this by using Seaborn, and then I've used PLDs. So this basically shows us another. So instead of using a histogram, we could use a pie chart to get a more. It depends on the user if he likes histogram more or pie chart more, depending on the visual representation. And lastly, I tried linear correlation, which was an RDD model I studied online recently while doing this model, and I found it really interesting. So Pearson correlation will basically weigh each column by another columns and return a value between -3 and 3. And this value will help us determine which column is more important compared to the others. So this is what I've written here. Pearson correlation can be used to weigh each feature against each other to find the most important features later to be used in an ML model. Um, so basically, I've done some testing here. So if we have df.d types uh, is a 2D array, and we can pass in it to get a 1D value. So this is how you do it. And then what I've done is uh, here, if you can see num features equal to a list I of 0 for I in df.data types if I of 1 is not equal to string. So as you can see here, this thing is I here, I of 0. So I of 1 will be this thing, the data type. So we only want to consider those features where the data type is not string. We need the numeric values. So if you can see here, in this table, we have this column and this column, which are numeric. We don't want to include them in our Pearson correlation because strings can't be compared to each other and return, and they will not return a numerical value depending on my string and z. So we only need the numerical values. So that is what we have done here. So basically, we're checking if the data type is not string, we will include it in this num features array. Then we'll again use df.select num features and we create a new object. And then we can use .pandas.head to represent this, but we don't need this. This was our required thing, which gives us a 2D array. I can show it to you. I'll run it really quick. And yeah, some features. Yeah. So we'll basically return you this array. And then I did everything, this thing for visual purposes. So this is basically, as you can see, we only get the numeric values. We don't get the last two columns that were yes and no and 125, the age categorization. So next we get the columns using another object and then use RDD, that is resilient data distribution, to analyze big data faster. So since this data is not very big, it doesn't matter a lot. But this what RDD does is it will use parallel computing to send different parts of code in different processors and compute it faster. So there's two ways to go through it. One, you can use the spark context.parallelize function and then create an RDD object and then use map. But I've decided not to use this. I've decided to use this, which is you basically call the data frame you have. You call RDD on that and then dot map, and then you pass the lambda function. So since we need all the values, since this X will be in the an array, I've passed all the values because we are dealing with all the values. So once you've done this, you can use .collect to print it. So you can see it gives us a very nice arranged a tuple, data in form of a tuple. Now this is our final thing, which is, so like I told you in the starting, instead of using sklearn, we use mllib on big data, which is why we use mllib here. So if you use this and you run this, it'll give us a very nice correlation between each other. So you can see when pregnancy is compared to pregnancy, it will return 1. When glucose is compared to glucose, it will return 1. But when pregnancy is compared to glucose, it returns a value between -3 and 3, that is 0.129. So this means that pregnancy is 0.12 times the values of glucose. So it is a type of linear correlation. And I can provide a link which will talk more about this correlation because I saw it online. I found it interesting and I thought I would do it and it would help an EDA. So yeah, this is basically just creating a statistics.co. We call the correlation function, and then we pass the features and the method is Pearson. There's other types of methods as well. And yeah, and then we just create a data frame. We give the index and column names, and then we print the object. And this is it. So yeah, this was my exploratory data analysis using PySpark. So what one can do ahead is once you get all the data features and their importance, you can go ahead and create an ML model which can predict. We have not done any prediction here. We have only done the exploratory data analysis, which gives the various features. You want to go ahead and predict, you can use linear regression models, polynomial regression models, or decision tree or random tree regressions. So in this case, if we see, we have 1, 2, 3, 4, 5, 6. We have a lot of dependent features. So one thing we could do is either find the most important features and then use multiple or polynomial regression, or we could use a tree regression as well. But it depends on the kind of uh, outputs the result the user wants. So that was it about this EDA, and I will be sending you this video link. I will be providing this video link here in the file along with the dataset file. And please let me know about your inputs, what you think about this, where I need to improve, and then we can go ahead with our meeting whenever you're free. Thank you.